Now, the secret to DOGE. Do you guys know about DOGE?
Yes.
Okay. The secret is they're not doing anything new. Because any of us that survived industry have seen these things before. Example, the idea of killing everything off and then just waiting to see who screams. When I was in the nuclear power, I had to, it was my job to trot up, this is 1991, we didn't have a freaking computer network. It was SneakerNet. I had to trot myself up to the control room every morning and sort through a box of reports to find the Unit 2 efficiency numbers and then take them back down and then type them into a spreadsheet. I kid you not. Now, every morning when I would go, the box was full of reports because that printer, big green bar, old style printer, would start printing off at midnight, and then the reactor operators, when in their spare time, would cut this stuff apart into the separate reports, and I would have to dig through the other reports to get to mine. One morning I showed up and the box was empty. I said, "What the hell, man?" And I knocked on the door of the control room, but of course no one answers because they're controlling a nuclear reactor, right? No one answers, so I go back down to my boss, and I'm like, "Hey, there's no report." So he calls up to the control room, and they're like, "Oh yeah, we just stopped doing that, and we'll see who misses the reports." By the next week, when I went back to get my report was the only one in there. In other words, they've been wasting their time doing all this other stuff. But if they had asked all those individual people, "Do you want to keep seeing these reports?" what will people naturally say? "Well, yeah," right? And so that's number one. Number two comes from the movie Office Space. Have you seen that? Yeah. Oh, you gotta see it. Yeah. It's entertaining and informative. Okay, so the part where the consultants come in and they're asking people, "What do you do?" And some of them can't explain what they do. Does that sound an awful lot like sending someone an email saying, "Name 5 things you did last week"? Now here's what I think's fascinating. Some people got upset. I'm like, I could sit down easily and come up with 5 things I did last week. I'll bet you guys could too. And then people are upset with this. My wife, being a former government worker, was not surprised at all with this outcome. Okay, now here's what it boils down to. Do you guys know what an enema is? If you don't, Google it. I'm not going to explain it. But every organization needs enemas now and then. The last time our federal government had an enema was in the 1980s under Ronald Reagan. That's the last time. That's a long time to go without an enema. And by the way, as far as I can tell, Missouri State University has existed since 1905 in an enema-free state. Because we really need to go through and clean out some of the stuff that we've got. Nobody's using it, it's waste, it gives opportunities for fraud, but we don't have our version of DOGE to make that happen. Questions? Okay, let's get started here. So the last time, and I say the last time, it was on the video, right? I was talking about systematic and unsystematic risk. Which are the ones that we have to worry about if we have a well-diversified portfolio? Yeah, the systematic risks. They're the ones that affect a lot of assets or all assets. And then we have the unsystematic risks. And why do we not have to worry about unsystematic risks?
Diversification.
Yeah, if we diversify our portfolios, then we don't have to worry about unsystematic risk. Okay, so which ones are priced, therefore, in the market? Yeah, it's got to be the systematic risk, because I can get rid of unsystematic risk. Okay, now let's take a look at what happens when we diversify our portfolio. So some of my finance professor colleagues decided they would run this experiment, and they programmed a computer, and they told the computer to go out 10,000 times and pick one stock and at random measure the standard deviation of the returns on that one stock and throw it back in the pond. And then pull a stock again and then do that 10,000 times. And when they did, the average standard deviation for that one stock was 49.24%. Then they said, "Okay, computer, I want you to go out and I want you to pick 2 stocks. And I want you to build an equally weighted portfolio, meaning 50% of stock A, 50% of stock B, and tell me what is the standard deviation of a portfolio composed of those two stocks. And do that 10,000 times and tell me the average. And the average was 37.36. Now they said, here's what we're going to do. We're going to benchmark everything against the standard deviation of one stock portfolio. We're going to divide the standard deviation of the new portfolio by that, and it's going to give us basically the percentage of the risk that's still there. And lo and behold, look at what happens between going from 1 to 2. We lose 24% of the risk just by holding 2 stocks instead of 1. We lose 24% of the risk just by holding 2 stocks instead of 1. Now we tell the computer, go out and pick 4 stocks and have a 25% weight on each one of those, and tell me what is the standard deviation of that portfolio. On average, out of those 10,000 draws, it was 29.69%, which is 60% of our original number. Now I want you to notice something here. Have we still reduced the amount of risk by doubling the amount of stocks? We have. But did we reduce it by as much? No, we didn't. Notice we dropped 24% on that first one. We've only dropped 16% on the second one. And then forget 6, let's go to 8. 24.98%, and we are down to 0.51. So we've gotten rid of 49% of the risk, but we've only dropped 0.09 this time for an additional doubling. So here's what we know. We can reduce risk. The reduction of risk is at a decreasing rate as we add more stocks. And so going from 1 stock to 2 stocks does you a whole lot more good than going from 100 to 101 stocks. However, going from 100 to 101 stocks still does do you some good. And in fact, we can see what happens here when we go all the way out to, let's start looking at 100. Or is it 200? It's hard to look on the screen and know. Okay, so we notice over here at 200, it starts to be 39%, 39%, 39%. Don't be fooled. That top one is probably 0.394, and then the one below it is 0.392, and then it's point. Do you see how this works? It's becoming what we call asymptotal. So an asymptote is a line that gets closer and closer, or an asymptote is actually the line that the curve gets closer and closer to, but never quite touches. Think about an airplane coming in for a landing, and every 100 meters it moves forward, it drops half the remaining distance to the runway. It's going to get closer, 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 closer to the runway, but is it ever going to touch down? No, because it's always only dropping half the remaining distance. And so you end up with this flight pattern that looks like this, where you're coming close to the runway, but never quite landing on it. And that's what we're going to see happens with risk when we diversify. Now, just looking at this chart, how many stocks would you say you would need to have a well-diversified portfolio? Yeah, I would say 200, right? Now, personally, I've got at least 1,100 in mine, and you say, wow, you've been out picking a lot of stocks. Absolutely not. How have I got 1,100 stocks in my portfolio? S&P 500 and the S&P 600. 500 plus 600 is 1,100. And then I've got some other stuff that I bought when I was a stupid young man and thought I could pick stocks. And I'm just too lazy to sell it off. It's not worth much. It would be a nice dinner with the wife, right? Okay, now, I'm talking to my dad one time. And we're talking about the importance of diversification. And I said, do you have a well-diversified portfolio? He's like, oh yeah. I said, how many stocks do you have in your portfolio? And he said 12. Let's go with 10. It's the closest number we've got up there. What percentage of the risk has he gotten rid of? He's gotten rid of 51%. And what percentage of the risk have I gotten rid of? 61%. But it's even worse than that, because when I bring this up to him, he says, oh, but it's okay because they're all electric utilities. What do you think the correlation between those things is? It's going to be pretty high, right? So he's not even as diversified as this number might lead you to believe. Now, has he done okay? Of course he has. Is he going to starve? Absolutely not. But could he have, it's so funny, one time he asked me, we were, because this is what loving families do at Christmas, we're comparing portfolio sizes. And I told him, and he knew how much mine was last year, and he's like, wow, how did you, have such high returns? And I said, it's the S&P 500. And he acted like I was cheating. Is it cheating to buy the S&P 500? Hey, if it is, count me in, right? This is one of the few kinds of cheating that I'm going to say is okay. Okay, any questions so far? Okay. Now, for those of you who are more visual learners, this is the same information only on a graph. And so we start with one stock in the portfolio and we go out to 1,000. And we start graphing there at 49.2% for one, and then we keep coming down, 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 down. But then we hit an asymptote. What's the number for the asymptote here? 19.2%. So basically, it doesn't matter how many more stocks I put on beyond 1,000, I'm never going to get below 19.2%. Am I going to improve slightly with each additional non-perfectly correlated stock that I add? Absolutely I am. Is it going to make a huge, huge, huge difference? No. That's why I'm sitting here feeling perfectly fine having 1,100 stocks instead of trying to go out and, by the way, I think there's a Russell 2000 and there's some other things out there. By the way, there's probably overlap between S&P 600 and Russell 2000. I could get some additional, but I really don't feel the need because of this asymptote. But there is additional tiny, tiny, tiny gains that can be made. Now you can start to see diversifiable risk versus non-diversifiable risk. That diversifiable risk, or the unsystematic risk, is that brown baby poop color there on the top. We can get rid of that. As we add more and more stocks, that goes down, and the diversifiable or unsystematic risk goes to zero. Does the total risk go to zero? No. Total risk is those two things added together. By the way, most commonly missed question on the next exam. As I add more stocks to the portfolio, and it should be something along the lines of unsystematic risk goes to zero, or total market risk becomes asymptotic at the systematic risk, or something like that. But instead, people will often choose total risk goes to zero. Wrong. We cannot get rid of all risk. We can only get rid of the unsystematic risk. Questions? So that baby blue area, that systematic risk, we can never get rid of that. So far, we have been using standard deviation as our measure of risk. That is actually a measure of total risk. The other names you may hear for that is market volatility, or the volatility of the stock. That's the return standard deviation. But that's total risk. It contains both systematic and unsystematic risk. Now, we said that only one kind of risk is rewarded by the market. Which was that? The systematic risk is the only one that's rewarded by the market, and so we need to have a measure of that systematic risk. And the measure that we're going to develop is called beta. Beta is going to be this measure. Now, we've already talked about why the market's only concerned with systematic risk, because you can diversify away the unsystematic. So how do we come up with this magical beta? The answer is something called the characteristic line. And basically what we do is we take the return on the security as our vertical axis, and we take the return on the market as the horizontal axis. And then every day, we plot the returns of both. And then through, in this case, we only have 2 points, so it's really easy to find the line, right? We're going to see down the road that it's linear regression is how we would achieve this line in reality. But what we're going to do is plot this line, and then we are going to find out the slope of the line. And we're going to refer to that slope as beta. So how would I interpret this? Let's start out here and talk about this slope. It says the beta is 1.5. What that means is slope is rise over run. That the security return is going to go up 1.5% for every 1% the market goes up. Let me say that again. The security return is going to be 1.5 times that of the market. What if the market returns 2%? How much would I expect the security to return? 3, right? Because it's just 2 times 1.5. Now, what if and by the way, at this point, you're thinking, wait a minute, the higher the beta, the better, right? Because I could have a beta of 3, and then when the market was up 1%, my stuff would be up 3%. Doesn't that sound cool? It sounds cool right up until what? Yeah, the market starts to go down. When the market goes down 1%, this stock goes down 1.5%. And when the market goes down 2%, this stock goes down 3%. And if beta were 3, it would be moving twice as fast. Now, it's going up twice as fast, but it's also going down twice as fast. Remember when we talked about how roughness on the return line was an indicator of risk? So here's something with a beta of 1.5. Here's something with a beta of 3. Can you see that the higher the beta, the greater the risk? The higher the beta, the greater the risk. Now, we're going to see that a negative beta's got some weird outcomes, but we'll get to that here in a little bit. Are there any questions about the characteristic line? Okay, let's talk about betas for various selected stocks. By the way, if you had to guess, what do you think the beta is for the market? It's got to be 1, right? Because for every 1% the market goes up, the market goes up 1%. It's got to be 1. And so what that tells us is anything with a beta of less than 1 has less systematic risk than the market. Anything with a beta of greater than 1 has more systematic risk than the market. American Electric Power. Anybody here familiar with American Electric Power? No, okay. What do you think that they make? Electric power, very good. Okay, now let's talk about why this beta is low. Today you get the news. Ms. Holden is waiting on a call back from a recruiter. Let's say she gets the good news that she's got a job. We're optimists here, right? Okay, so, and we know you're great. Okay, so, when she goes home tonight, is she going to say, wow, I just got a job. I'm going to turn on all my lights. Yeah, right? Conversely, now we're big pessimists. Conversely, they call her up and they say, no, we're not going to hire you, sorry about that. Does she go home and turn off all the lights and sit in the dark?
I might have to.
Yeah, I don't recommend that. I don't recommend that. I've done that, but I don't recommend it. So what I'm telling you here is, even in great economic times, we're not like going around and turning on extra lights. In bad economic times, we're not necessarily going to sit around in the dark. Now, we will be a little more careful about leaving lights on, but it's not going to be a huge effect. Now, it used to be that we were an industrial nation and a huge amount of our electricity was consumed by industrial production. And the beta of the electric utilities would be higher as a result because in bad economic times, people buy less stuff, you produce less stuff, and so forth. But now we're primarily driven by consumer consumption. What do you think is true in China of electrical consumption? Most of it is actually industrial. And so the beta, if you had a publicly traded electric utility in China, the beta would be higher because it's more susceptible to what's going on in the economy. Water is the same way. I hope that when you go home and you have gotten good economic news, you don't like to go around flushing your toilets extra, or what's worse is cutting down on flushing during bad times, right? I once had a roommate from California, and I would find presents in the toilet. He's like, dude, we got to save water. I'm like, dude, you are in Arkansas now. We have plenty of water. Flush the damn toilet. Okay, now let's talk about Johnson & Johnson. What does Johnson & Johnson make? Band-Aids, health stuff, right? Okay, so let's take Band-Aids for example. You cut your finger. You're like, oh, damn, bad economic times. I better just let that bleed. No! Or, good economic times, you're like, I'm feeling wealthy. I'm going to put 2 Band-Aids on that. No, it doesn't work like that. Tyson Foods, they do produce beef, but what's their primary thing? Chicken. Is chicken rich people food or poor people food? And I love chicken, don't get me wrong. It's poor people food, and here's why. It takes 4 pounds of grain to put a pound of meat on a chicken. It takes 10 pounds of grain to put a pound of meat on a cow. So which is going to be cheaper? It's going to be the chicken, right?
Sorry, are we, like, because of the bird flu right now, like, would that beta ever change?
Yeah. Oh yeah, so now we've got scarcity of chickens, right? And the cows are like, yeah. So let's assume that 1 out of every 2.5 chickens dies. Then we're still in essence putting 10 pounds of feed and getting 1 pound of meat, which would lead us to assume that the price of meat and chicken would reach parity.
So
Yeah.
would the beta ever change, or is that like saying?
Well, actually it would, because now that chicken is more expensive, what does that mean about people's willingness to buy it in hard times? They are less likely, right? So the beta of Tyson would go up.
Okay.
Because of, yeah, that makes perfect sense. I had never thought of it. You're absolutely right. Okay, yeah, nobody says to their friends, hey, I just got a big promotion at work. How would you like to go out for chicken? No, what do you go out for? Steak, right? Okay, so that's why you see Tyson being below 1. Allstate's an insurance company, and it's about as close to 1 as we're going to get here. And 3M, what does 3M do? Sticky products, lots of stuff. They've got a plant here in town, right? They do all sorts of stuff. They have a diversified portfolio of products. Do you start to see how, yeah, so they're really, they kind of reflect the overall market, the overall economy, so we're going to say they're close to 1. Hewlett-Packard, what do they do?
Printers.
Yeah, printers, computers, and we're going to throw them and Dell together here, printers, computers. And we see that those things have a beta slightly higher than 1. And here's why. When times are good, I remember this at the nuclear plant. When times were good and we had lots of money to spend, we would update all of our computers. Actually, that's how we got computers the first time. I'm not kidding. The first time I started working in the nuclear plant, there were a total of 2 PCs of the whole place. 1,400 employees, 2 PCs. Now, we had some dumb terminals, but there were only 2 PCs. Oh. Then we ended up, 1993, we had extra money in the budget. 92, we had extra money in the budget. And so we all get these desktop PCs. Now, none of us know what to do with them other than to play games. But what happens beyond that? When you've got money, you upgrade your hardware. When times are hard, what do? Yeah, I'll bet this could last another year. I can tell you this, when I worked in industry, my computer got updated a lot more often than it does now that I work for the government. There's just not, there's just not all this money flowing in, right? Okay, now, AIG. I have to confess, this slide was snapshotted right after the financial crisis. Does anyone know what happened to AIG during the financial crisis? It damn near died. And here's why. AIG was selling some risky financial insurance products on subpar mortgages and crap like that, and they got burnt bad. Almost died. Uncle Sam reaches in and bails them out. Actually basically buys the company. And then, so what do you think happens to the stock price? It's like really low, right? Because everyone expected him to die. Well, what does that mean when things came back to normal? Well, their stock price jumps up faster than other stocks. Now, if you looked at AIG today, I highly doubt it would be 1.81. And here's why. Number one, we've reached more normal times. And number two, after all that, do you think the government's allowing AIG to play with these very risky? No, no longer allowed to do that. Now, let's talk about this formula down at the bottom of this slide. This is an important formula. Let me say that again. This is an important formula. Beta is equal to the covariance of the return on stock I and the return on stock N divided by the variance on the return on the market. Oh, and I've switched up. I was doing English and I went to Greek, so sorry about that. Okay, so that is beta. We know that correlation and covariance are related. Remember we said, what did we say? Correlation is equal to covariance divided by the standard deviation of each of the different things. You guys remember that? Okay, so we can actually rewrite this and say that beta is equal to the correlation times, and then we're going to multiply by these two things, standard deviation of R, standard deviation of I, divided by, I'm going to go back to the, oh sorry, this should be market. So now I've got the standard deviation of the market up here, and I've got the variance of the market down here. What can I do? I can cancel. And so I can actually end up with another formula for beta, which, by the way, you should have on your note sheet. And that is that it is the correlation between the asset and the market divided by the standard deviation of the return on the market. So, if I give you covariance, which one do you use? If I give you correlation, which one do you use? Does that make sense? Yes?
Where did the standard deviation of the asset go?
Ah, okay. Sorry, I missed that, didn't I? There we go. So I should go ahead and write that in the same way that I write everything else here. Thank you for catching that. And so then we're basically saying that this beta is basically related to the ratio between these two standard deviations multiplied by the correlation. Do you guys know Dr. Whitty? Mm-hmm. Dr. Whitty, by the way, he was my professor at the University of Missouri. Isn't that weird? When he taught this, he was teaching it this way, and he says, notice it has nothing to do with the standard deviation of the individual asset. And I'm like, oh yeah, he's absolutely right. Years later, I'm playing with the equations and I come up with this. Does it actually have something to do with the standard deviation? It does. Have I ever told him? No, he's a nice guy. I'm not going to mess up his dream there. Questions? Okay, should you have those on your note sheet?
Yes.
When you encounter a problem with these, what's the word you should read for? Is it covariance or is it correlation that they've given me? And when you know, then you can choose which equation to use. Okay, so now let's talk about calculating beta for a portfolio. Remember when we were calculating standard deviation for a portfolio, we had to worry about how these things move with respect to each other because there was this diversification stuff going on. But we know that beta is a measure of systematic risk. Is there any diversification going on when we're looking at betas? No, man. All we've got to do is have a weighted average of those betas. All we've got to do is have a weighted average of the betas. And therefore, finding the beta of a portfolio is exactly the same process we're going to use for finding the return. We're just going to find a weighted average. And what are those weights? It's the dollar amount of this individual asset divided by the total dollar amount of the portfolio. And when I add all those weights together, what should they always be equal to? 1. If they're not, you've got a problem and you need to go back and check your work. Questions? Okay. Now, let's talk about the security market line, or SML. This one's extraordinarily important. The security market line, basically, what we've done is we've swapped out down here on this bottom line, in our last look at risk and return, we were having standard deviation down here, but now we've got beta. Now we've got beta. And we see that it is purely a line. There's not a curve because there's none of this diversification stuff going on. That's already been taken out. We're looking purely at beta. And so we can actually come up with a formula for this line simply using algebra. I know you guys are algebra allergic. I'm going to try to prove to you it's really not that bad. Okay, I'm going to write a formula on the board, and depending on where you're from, you will recognize one of these two formulas. Americans, which one do you recognize? M. People from not America, where do you recognize? Yeah, the top one. Either way, this is the slope. And what is that? Y-intercept. You guys are on fire. Okay. I think we may be ready to talk about coming up with an equation for this line. And what we need to find any line are 2 points. And we know that the beta is the x, so we're going to call that one out first in our ordered pairs. If I have a beta of 0, what is the return? Yes, the risk-free rate. If there's no risk, you receive the risk-free rate. Now, what if we had a beta of 1? We said that the return on a security would be the same as the return on the market. And so we're going to say the expected return on the market. Now, why did I put an E here and not up here? Remember, expected values are swag, scientific wild-ass guesses. That's our best guess of what this thing's going to be. Do I have to make a swag at the risk-free rate? Hell no, it's risk-free, right? We know what it's going to be. Does that make sense? Okay, so now I've got 2 points. Anybody knows if I've got 2 points, I can put a line between those 2 points. I can actually find out what the, I can find out the formula for that line. Okay, so first thing I want to do is figure out slope. And it is equal to the change, it's what rise over run, is what my grandfather would have said. Change in y over change in x. Now, our y's up here are these. I'm going to call this location, or point number 2 and this point number 1. We're going to take y2 minus y1 divided by x2 minus x1. Have I blown anybody's mind? By the way, if I did these backwards, it would still come out fine. Okay, now, y2 is the expected return on the market. And then Y1 is the risk-free rate. And down here on the bottom, X2 is what? 1. And what is X1?
0.
0. So what happens to that stuff on the bottom? Anything divided by 1 is just that stuff, right? And so basically, that stuff just goes away, and we're left with the slope on the security market line being the market risk. Let's see. The slope on the security market line is this market risk premium. By the way, a risk premium is just the expected return of that thing minus the risk-free rate. So the risk premium for the stock would be the expected return on the stock minus the risk-free rate. The risk premium on the market is the expected return on the market minus the risk-free rate. Okay, so there we go. Now, students often get confused. And one of the questions I love to put on the exam is, what is the slope of the security market line? And the answer is the market risk premium. What students usually say is beta. Beta is not the slope. Beta is the x-axis. Beta is not the slope. Beta is the x-axis. Okay, so now we've got the slope, and we also need to figure out what is the y-intercept. Any ideas? By the way, what is the definition of the y-intercept? It's y when x is equal to 0. What is y when x is equal to 0? It's R sub f, right? It's risk-free rate. Okay, so now we are ready to write out our formula here. And y, in this case, is the expected return on the stock is equal to the beta, or the slope, which is expected return on the market minus the risk-free rate, multiplied by x. What's our x here? Beta. And we're going to say beta sub I plus the y-intercept. What's y-intercept? Yeah, the risk-free rate. So there we go. That's how you come up with the formula for the security market line. Now, typically, we end up writing it in this form here. We say it's the risk-free rate plus beta times the market risk premium. This is probably why students get confused and think that beta is the slope, but it's not. Okay, now let's talk about some different scenarios here. What if the beta of the stock is 1? What is the expected return on that stock? Say again?
It could be expected return on the market.
Yeah, it's just going to be equal to the expected return on the market. Why? Because it's the risk-free rate plus 1 times that stuff. So we've got risk-free rate plus the expected return on the market minus the risk-free rate. What happens to the risk-free rates? They cancel out, right? And so you're just left with the expected return on the market. What if beta is 0? Then the expected return on that thing is just the risk-free rate, because there's no risk after all, right? Now, here's the big question. And I haven't looked to see what the latest edition of the textbook says. So like 2 editions ago, it says about that there are negative beta stocks, and it actually named a couple. And then in the next edition after that, it said there are no such thing as negative beta stocks. And I'm like, wait a minute, what graduate assistant wrote that? And so I'm like, you know what? I'm going to go out and take a look for myself just to make sure that I'm not crazy. And I went out and I used, back then it was Ameritrade or TD Ameritrade. So I go out there and I use the stock screener. And I screen for anything with a beta lower than 0. That'd be negative, right? And it turns out that there are stocks that have negative betas. During the financial crisis, Walmart had a negative beta. But typically, the stocks that we see that continuously have a negative beta are gold mining stocks. Let's talk about why that is. If times are good, do I want to invest in gold? Let me ask you this question. Does gold produce any wealth in and of itself? If I take 2 gold bars and put them in my safe and I lock them up for 9 months, and then I open the safe, will there be a bunch of little baby gold bars? No, it's not going to happen. And in fact, gold, just if nothing else changes, loses value simply because you have to pay to store it because it's a physical asset. You got to pay someone to sit on it with a shotgun. Why do I have to pay someone to sit on it with a shotgun? I guarantee. So run this experiment when you get home with your gold bar. Put it out in your yard and see how long it takes for it to disappear, right? And then you say, well, wait a minute, no, I'm going to be smart. I'm going to put it on my coffee table. And then your crackhead friends come over, and when they leave, you realize your gold bar is gone. And then you say, oh, I won't put it out when my crackhead friends come over, only when my trusted family members come over. What's going to happen? Someone's still going to take it. Your worthless cousin Neville will take the gold bar, right? It's going to happen. Okay. Now, so we have to pay someone to sit on this. And so it has storage costs. And so basically, it's not only creating wealth, it has a tendency to destroy wealth at a small rate. And so why would anyone want to be invested in gold? Okay, so there's a diversification argument. And we'll get to why it's a good diversifying thing. When do people buy gold? When they're happy? When they're confident? When they're optimistic? No, if you're happy, confident, and optimistic, you're putting your money into the stock market. Because you can have stocks that actually create wealth, unlike gold. When do you put your money in gold? Are there a lot of people putting money in gold right now? Yeah. If you're one of these people who thinks everything's going to hell in a handbasket, do you keep your money in the stock market? No, what do? You sell it out and buy gold, right? So what does this mean? When the economy is going in the dumper, people are looking for safety, they go out and buy gold. What does that do to the per ounce price of gold? It goes up. So the price of gold is going up while the market's going down. If you have a gold mine, it turns out that your costs are pretty much the same regardless of the price of gold. And so when the price of gold goes up, your revenue goes up, but your costs stay the same. What does that do to your profits? Yeah, your profits go up. And what does that do to your stock price? Yeah, it pushes up your stock price. And so what we see is the prices of these gold companies goes with gold, not with the market. And since gold is moving in the opposite direction of the market, these stocks tend to have negative betas. Now, let's see what happens if we throw a negative beta into this equation. We are going to get an expected return on that thing that is less than the risk-free rate. Why on earth would I put up with something that's going to return less than the risk-free rate? The answer is, when does it pay off? So you've got your beta of 3 stock portfolio. It pays off wonderfully when times are good. But probably not as meaningful to you because you're also doing well at your job, you're getting great pay raises, you're getting good bonuses, and so it's just kind of like gravy on top. When do negative beta stocks pay off? Negative beta stocks pay off when your other stocks are in the toilet, when you've lost your job, and your woman has left you and taken your dog and your pickup truck, right? That's when that negative beta stock pays off. That's why we're willing to put up with such bad behavior, expected value of return less than the risk-free rate, during good times, because we know that during bad times, it'll be there to help us out. And this is all due to the marginal utility of consumption. Marginal utility of consumption. I'll demonstrate it. So spring break. You've decided you can't afford to travel very far, so you decide to go to Mark Twain National Forest, I think it's called. and you decide to go on a hike. And along the way, you see beautiful things, and you're Snapchatting, Instagramming your friends, doing a little TikTok dance, and by the end of the day, you feel really great inside because you're getting likes, but your phone battery is dead. And now you realize you are lost in the woods. Day 1, you start to get a little hungry, but you think, certainly someone will come find me. Day 2, now you're starting to get even more hungry, and you start to say things like, wow, that dandelion looks a whole lot like arugula. Maybe I could eat it, right? Day 3, you're amazingly hungry. You try tree bark and you try crickets, but they're all too crunchy and they're hard on your teeth. So you're really in a bad way now. And then you step out into a clearing in the forest. And there I stand with, and I've got a glove on, it's very sanitary. I've got a hot, fresh hot dog in my hand. How much are you willing to pay for the hot, fresh hot dog? Yeah, and I would take advantage of you like that, but let's assume that I'm a better person. I'm only going to charge you Disney prices, so I'm going to charge you $20 for this hot dog.
Costco prices?
No. Not when you're in the woods, right? We'll get to Costco in a minute. Okay, so I'm holding the hot dog, and you eat the hot dog. You give me the $20, you eat the hot dog. That was really good. Now, whoop, I magically produced another hot dog. How much are you going to pay me for this one?
Like $18?
Yeah, not as much, right? Why not?
Because like my satisfaction levels are getting to a plateau.
Yeah, she's still hungry, but she's not as hungry as she was. So her marginal utility of consumption has dropped. Now, whoop, number 3. How much? What's that? 10, right? And I'm going to keep doing this. Now, eventually, I'm going to pull up a hot dog, and you'll say, no more hot dogs. Does that ever happen with money? Does anyone ever say, oh, no more money, please? Only one person I've ever known of, the Vietnamese guy that did Flappy Birds. That's the only one I've ever heard of. I assume he's in treatment somewhere, because that's not rational, right? So the marginal utility of consumption is always positive when it comes to money. Okay, now, what is the negative beta stock? It's the first hot dog. Does that make sense? It pays off when you're hungry, when you're destitute, when you need something just to survive. Questions? Okay, now I want to point out something to you here. We can think about this formula in another way. The expected return on the asset is equal to the risk-free rate plus beta times something else. What is that something else? What do we call that thing? I told you earlier. Yeah, it's the market risk premium. And so I can do something here, and I'm just going to do it up here on the board. I'm going to subtract the risk-free rate from both sides. Oh, sorry. Have I done anything weird, magical, mystical? No, I just subtracted the risk-free rate from both sides. We know that this is the market risk premium. What's this thing? Yeah, it's just the risk premium on that security. So we're going to call it risk premium I. And so basically, in order to find the risk premium on any asset, all we have to do is take the market risk premium multiplied by beta. And in fact, we could take one more shot at this and say that beta is equal to the risk premium on the stock divided by the market risk premium. So if stock has a beta of 3, its risk premium will be 3 times higher than that of the market. It makes sense. The risk premium is what we get paid to bear risk. If you're bearing 3 times as much risk, how much premium are you going to expect to get? 3 times as much. Does that make sense? Okay, now be careful when you are working these problems, because sometimes I will give you the expected return on the market. Sometimes I will give you the market risk premium. If I give you the expected return on the market and you're using this formula, you need to remember to subtract out the risk-free rate. If I give you the market risk premium, do you need to subtract the risk-free rate? No, and if you do, you will surely be wrong. So, read first. It's like reading whether I've given you covariance or correlation, right? Read first. Questions? So how do we find beta in the real world? Well, I'm going to pull up Excel here. I'm going to try to make it as big as I can so you guys can see. And you can tell how old this example is. I pulled this data in January of 2008, right? So, but it still works for what we're going to talk about here. And I've got several different columns of data here. The first is the risk-free rate. The risk-free rate data by the way, we always use, what's our substitute for the risk-free rate? The 3-month Treasury bill. We always use the yield on a 3-month Treasury bill as our stand-in for the risk-free rate. Now, where in the world would I find such information? It turns out that we have 12 Federal Reserve banks in the United States, and did you know that Missouri is the only state to have 2? Doesn't that make you feel special? Our state has 2 Federal Reserve banks out of 12. It's amazing. Okay, now, what else do these Federal Reserve banks do other than, like running the world economy? They have data. They have data, and that data is freely available to you. And so you can go to the Federal Reserve website. If you're from St. Louis, you want to go to that one. If you're from Kansas City, you want to go to that one. I go to Chicago because I'm a big old nerd. Anyway, long story short, they've got this data, and that's where I went to download this. This is from the Federal Reserve. So that's where that column of numbers comes from. And I get one of those for every single day. And then the next column over is the stock price for GE, General Electric. Stock price for GE. I then use that information to come up with a return for GE. How do I come up with a return for GE? Well, all I have to do is take today's stock price minus the last stock price, which in this case was today's Monday, so it would be Friday, and then divide by that last stock price. And then that gives me the return on GE for that day. That means, though, down here at the bottom, that not only do I have to have data for 2007, I also have to have the data for the very last day in 2006, or I can't calculate this stuff. Okay, now, so that's how we get the return on GE. Then I can figure out the risk premium on the stock. The expected return minus the risk-free rate. So each day here, I'm taking the return minus the risk-free rate. That gives me the risk premium for that stock for that day. So now I have all the information on the stock that I will need to calculate beta. But I also need stuff for the market. Now, we typically use the S&P 500 as our stand-in. And for some reason, the day I was downloading this, I could not find the S&P 500 numbers. But I could find the price for SPY. What is SPY? Yeah, it's an ETF that follows the S&P 500. And so if the S&P 500 is up by 1%, how much is SPY up? 1%, right? So I'm like, easy enough, I'll just use SPY. So I plug it in, and I find the return on it the same way, and then I find the market risk premium for every day the same way as before, where I take the return minus the risk-free rate. Okay, now we have all this data. how are we going to go about? And basically what we're trying to do here is come up with something looking like the characteristic line. But a little bit different, because in this case, what I'm doing is I'm treating this as my y, and this as my x. I'm trying to figure out what the coefficient is on x, or the slope, and then we know that basically the y-intercept here would be 0, because there's nothing else hanging out there. So when we get done, our coefficient on this market risk premium, which we're treating as x, is going to be our estimate of beta. Now, how do I figure that out? I use something called linear regression. And I'm going to start out like this. I'm going to hit data. And if the tools were already loaded, you'd see data analysis over here. But we don't. So what do? We go to File, and I go to More, Options. They really hide this crap. Data. Is that it? No. I'm going to say add-ins. There we go. Add-ins. And I'm going to say Manage Excel Add-ins Go. And I'm going to click on Analysis Toolpack. Now, what's the difference between Analysis Toolpack and Analysis Toolpack VBA? I have no idea. I'm not a VBA kind of guy, so I just click the top one and it all works, so there we go. And when I do that, notice that now I've got data analysis populated up here. I'm going to click on that. And notice it's got all sorts of amazing crap you can do with this. My wife's discipline is really into this ANOVA thing. We're into correlation covariance. But the thing we're really going to be looking here for is a regression. And now it says to input the Y range. And we said we're going to use the risk premium on the stock as our Y. And so I'm going to go here, and I'm going to use that risk premium on the stock as my Y. By the way, typically 252 trading days in a year, unless something funky happens like September 11th or leap year or something like that. Okay, so now we're going to input the X range. And we said the X range here is going to be the market risk premium. So I'm going to get that return on SPY minus the risk-free rate. Oh, no. Come on. Actually, what can I do? I can start here at the bottom and work my way up. There we go. Make sure that they match 2 and 252, right? Okay, now I'm not going to put any labels on this. I'm not going to tell it the constant is 0, but we're going to see that it's going to come out to be pretty darn close. And I'm going to have this come out as a new worksheet. So I'm going to say OK. And here is that new worksheet. Now I'm going to go through here, make this stuff bigger so we can all read it. Okay. Now let's do a little interpretation here. Forget the multiple R. The first thing we're going to look at is R squared. R squared is a measure of how well X accounts for the variation in Y. Now, in this case, it looks like we can explain 60% of the variation in GE stock simply by the market returns. And you say 60%, that's really not that great. Let me give you some things to go by here. When I was in engineering, our R squareds were like 0.98. 0.99. Why? Because we were modeling physical phenomena, right? The charge on an electron. We could do that really easily. Now, if you go to the other end of the scale, when you get down to the social sciences, we tend to have R squareds much lower. I have publications in good journals with R squareds of like 0.03, where I was explaining merely 3% of what was going on, because it was 3% more than people had explained previously, right? Does that make sense? Now, so with those two goalposts in mind, this 60% actually I think looks fairly good. Now let's talk about Adjusted R squared basically just adjusts for the number of things that you're throwing in there, because you can always drive your R square up by throwing additional stuff in there. I guarantee you, if we threw the price of butter in Denmark in here as one of our things, we could add that in and we would get a greater R squared. Would it be meaningful? No, hopefully not. And if it was, we would start to have to wonder about what was going on with butter in Denmark. Okay, now going down here, we see this significance, the F test. So what the F test tells us is, are the coefficients in the regressions significantly different from 0? And this number is so darn low that we can say that it's significantly different from 0. We're not going to worry about that. Here's what we really came for, these coefficients. And we said that the coefficient on x is going to be beta. So our estimate for beta for GE here is 0.89. And remember we said that the beta of the market is how much? 1. GE, boring old industrial company, diversified at this point across many sectors of the economy. Does that sound right? Yeah, 0.89 sounds about right for that. Okay, now what about our y-intercept, which I said would be 0? We've got negative 7.07 times 10 to the negative 5th. And in case you're not interested in scientific notation or you're not familiar, this is what that means. It's 0.00007. And keep in mind here that 0.01 is 1%. And so we're like way south of 1% on that intercept. We might as well say that it's 0. And in fact, we can look at the t-statistics. Hopefully you guys remember t-statistics. If I said that a t-value is 5, would you tend to think that's significant or not significant? Yeah, significant. So I start looking around 1.96 for significance, and then the higher it is, the better. What is the t-stat on our beta? 19.33. That is some significant stuff, right? What about our t-stat on the intercept? It's almost 0, right? And so basically what this is telling us is that the y-intercept is not statistically significantly different from 0, which is exactly what we expected. Now, can I ask you to do linear regression on an exam? No. Why do I teach it to you? This is a helpful tool. At some point in your life, you're going to need to figure this stuff out. And I want you to remember, now the tough part will be remembering how all the steps we had to go through to get that thing installed on our machine. The good news is, once you get it installed, it stays, right? Questions? Okay. Let's tippy-toe into bonds. So let's talk about what bonds are. A bond is an interest-only loan. Remember when we were in chapter 4, when you were doing your review, we said there were 3 kinds of loans out there. A discount loan, which is where I basically borrow $900 today and promise to pay back $1,000 on the due date. And so the interest and principal all gets paid at the very end. And then there is the amortized loan, where each and every payment represents a payment of both principal and interest. The third kind of loan we discussed was the interest-only loan. And that's where I borrow the money, and over time, all I'm paying on that is the interest. I'm not paying down the principal at all. And so at the end of that, I owe the last interest payment plus the principal amount. It turns out that bonds are interest-only loans. That's how they work. They just make these interest payments along the way, and then at the end of the bond's life, you pay that last bit of interest and the amount that you borrowed, the face value of the bond. So we have some vocabulary here. The borrowers are bond issuers. The borrowers are bond issuers. And they sell bonds to the lenders. The lenders are the bond buyers, or we could also call them the bond holders. And so if I'm a company and I want to borrow money and I don't want to deal with the bank, I can issue bonds. You guys buying those bonds represents your loaning of money to me. It represents my borrowing from you. Now, the borrower is going to pay interest periodically throughout the life of the bond. Typically twice per year, sometimes once per year. We'll talk about those differences in a bit. And then at the end, the borrower pays the remaining interest and all of the principal at the end of the bond's life. So here's what the payments of the bond look like. Interest, 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 and at the end, interest plus principal, the entire amount. Okay. Let's talk about some vocabulary. Coupon. Anybody's mother here cut coupons out and take them to the store? That was a very big thing to do in the 70s. My mom would get Ladies' Home Journal, cut out the coupons, and we would have Cool Whip. It was great. Okay, now, coupon is apparently a French word that means a little piece of paper cut off of a bigger piece of paper. Because when bonds were originally started, they were just big pieces of paper, and at the bottom they had these little coupons, and you would cut the coupon off, and you would take the coupon in, and they would give you your money. And so each one of those interest payments became referred to as a coupon. Now, today, you will find there are very few bonds that still have the little paper coupons, but finance people are really bad at holding on to an idea for far too long, and so we continue to refer to those interest payments as coupons, even though there aren't, most of the time, any little coupons involved anymore. So those are the interest payments. And then we have the face or par value. Remember I told you at the end that the entire amount of principal would have to be paid? That would be that face or par value. Now, in most cases, you can use those things interchangeably, but I'll give you some examples of when we don't use them interchangeably. And then we have the coupon rate. Oh, by the way, default face or par value is $1,000. Default face or par value is $1,000. Default face or par value is $1,000. If I do not tell you the face or par value of the bond, Mr. Ellis, what do we assume? $1,000, right? I guarantee at least one of you is going to be working through the practice or the homework, and you're going to be saying, that bastard did not give me enough information to solve this problem. And when you say that, I want you to say, I'll bet he didn't tell us the face value, and it's, by default, $1,000. Does that make sense? Okay, now the coupon rate. That is the rate that I multiply by the face or par value to come up with the annual amount of coupon paid. It is the rate I multiply by the face or par value to find the annual amount of coupon paid. Now notice I'm saying annual amount there. If I want to find the amount of the individual coupons for a bond that pays twice per year, I'm going to have to cut that number in half. I'm going to have to cut that number in half because the coupon rate gives us the annual amount of coupon paid. Maturity. Maturity tells us how long this bond has until they have to pay us back that face value and the last interest payment. So typically bonds, you're going to see them up to 30 years in length, out to maturity. And then you'll see some, I'll give you an example here in class of one that went out to 100 years. And in fact, there are some that go on forever. Britain and Canada have issued bonds called consols that have no maturity date whatsoever. The price. The price is what people would be willing to buy the bond for today in the market. And bond prices, just like stock prices, go up and down based on market conditions. Bond prices just like stock prices go up and down. Now, sometimes students get price and face value confused. In the overwhelming majority of cases, except for unless it's a sort of weird bond, that face value stays the same for the entire life of the bond. But that price changes every day based on people bidding the bond prices up and down in the market. The yield to maturity is the required return on the bond. The yield to maturity is the required return on the bond. And it is expressed as an APR. Yield to maturity is expressed as an APR. And so if I've got a bond that pays twice per year, and it's got a yield to maturity of 12, my 6-month interest rate would just be 6. I have to divide by 2. So yield to maturity is an APR. Now, what you need to understand is that the value of a bond, the price, is just the present value of all the expected future cash flows. The present value of all the expected future cash flows. And each one of those future cash flows, I can calculate the present value like this. And then I can add all of those together. This R is yield to maturity. And so what we see as that yield to maturity goes up, what happens to the bond price? It goes down. And as yield to maturity goes down, bond prices go up. It's so funny. This is a mathematical, mechanical relation. It's never going to change. But whenever I read an article in the Wall Street Journal about bonds, they always have the sentence, bond prices and yields move in opposite directions. Now, why do they have to do that? Because not everyone is as educated like you are. And so they have to throw that out there for people who are new to the bond world. But here's what you need to know. Yield to maturity is going up. Bond prices going down, yield to maturity is going down, bond prices going up. Why do you think I stand up here and make a fool of myself like this? So you'll remember, right? So you'll remember. By the way, what would make the yield to maturity go up? Blank and return. What's the first word? Starts with an R. Yeah, risk and return, right? We know that risk and return have to go together. Now, in yield to maturity, we're going to see that there are all sorts of risks that are bottled up in there. There's default risk and other things. But the riskier the company is, the higher that yield to maturity is. The riskier the overall interest rates in the economy, the greater the yield to maturity is going to be. So assume today that interest rates went up by 0.5%. What would happen to damn near every bond price in the country? Down, right? Or when they cut interest rates, it goes the other way. And we're going to see that your well-being can be totally tied up in what's happening with interest rates today if you are a bond investor, because your wealth can change dramatically. If interest rates go up quickly, like when the Fed is fighting inflation, we end up with what's called a bond market bloodbath. What does that sound like? Is that good? No, that's where bond prices are, right? Okay. Any questions? Okay, for next time, more Chapter 5, bring both sets of slides, and let me know if you have any questions. Bring your ID, your calculator, if you want to review your exam. Make an appointment if you have not already.